A very good morning to the examiner and doctor. My name is Bong Nian, AN200186. I will propose the title Smart Flood Warning System using IoT for BNR 322803 PSM1. This is our overview of the slide, our theme, introduction, project description, problem statement, aims and objective, residual review, methodology, expected result. Our team, me as a student, and TS Muhammad Fadli bin Abdulrazak as the supervisor. The introduction part. The smart flood warning system using IoT is a technologically solution designed to provide real-time alerts and warning to the people living in the flood-prone area. The component consists of sensor, gateways, and cloud platform. Location we test is river and the lakes. Data collected will include the water level, flow rate, and the rainfall. Promising solution that the power of the technology to improve flood response and ensure public safety by providing timely and accurate information. The system can prevent loss of life and property and facilitate quick recovery effort after floods. Our project description. It is an automatic flood warning system. It can predict the flood risks with data collected from the sensor deployed around the flood-prone area. It can help in reducing loss of life and property. It automatically analyzes the data and sends the warning message to residents nearby the area through the apps. This device is constructed with a microcontroller which is ESP32, ultrasonic sensor, rainfall sensor, water flow rate sensor, and power supply and the wires. The problem statement. Flood is the common natural disaster that can cause significant damage to the property, infrastructure, and human life. In recurrent years, there were several flood accidents reported in various regions including Batu Pahat, Johor, Malaysia, resulting in significant loss to property and human life. Existing flood warning system limitation consist like delay warnings, insufficient data accuracy, and limited coverage. Furthermore, they rest on manual data collection and lack the capability to provide real-time update. Our project aims and objective: develop a comprehensive smart flood warning system that integrate various sensors, including ultrasonic sensor, rainfall sensor, and water flow rate sensor with an ESP32 microcontroller for real-time data collection and analysis. The objective consists of two. The number one is to develop a flood monitoring system which automatically collect and process the real-time data of flood monitoring. The objective two, to obtain the meaningful information from sensor through calibration and comparing to the actual manual measurements. The project scope: to develop an automatic IoT device in real-time data collection and analysis of critical parameters such as water level, rainfall intensity, and flow rate and water flow rate using the ESP32 microcontroller and sensor like ultrasonic sensor, flow rate sensor, and rainfall sensor. The project scope 2, to implement a calibration process and perform comparison between sensors measurement like ultrasonic sensor, rainfall sensor, and water flow rate sensor and manual measurement to extract the variable information. Now we will continue to the chapter 2, literature review. Now is the literature review part. Comparison of previous project. From the 5 previous projects, we compare the advantage and disadvantage. For example, project 1, the microcontroller has an inbuilt Wi-Fi module, but the disadvantage is incomplete weather forecasting may affect the accuracy of data and flood prediction. The previous project 2, combination of different microcontrollers to build the system more accurate with several sensor. But the disadvantage is cost of this system too high due to several microcontroller like Raspberry Pi, Arduino. The benefit of previous project 3, cost of build this project more economically, but the sensor like ultrasonic sensor can be affected by the environmental factor. The previous project 4 have the advantage, which is the clustering predictive technique increase the accuracy of flood prediction, but this clustering prediction requires some technical expertise. The previous project 5, the microcontroller is is energy efficient, low power consumption, but same as the previous project 3, the ultrasonic sensor have the limited detection range. Now is the methodology part. This is our project progress flowchart. Start with choosing the project title. We will get the advice of the supervisor whether if approved or not. If approved, we will proceed to the preparation and planning. The preparation and planning include the chapter 1 proposal, introduction, problem statement, description of project, project aims, objective, scope, layout, design, flowchart and Gantt chart. The proposal after is done, we will pass to our SV to check whether it's okay or not. It's okay, we will proceed to the next chapter, chapter 2. We will start the introduction, previous project and comparison, other related information, related literature review, discussion. Is the chapter 2 okay? We will pass to the SV for the review. Is approved, we will continue the part 3, which is methodology. The methodology including introduction, block diagram, flowchart, 3D layout diagram, list of software and hardware. We will, after done the part 3, we will pass to our SV for review. It's okay. All the PSM 1 result we will submit to the author and presentation and end. System block diagram. Our sensor include of 3 ultrasonic sensor, 4 rate sensor, and rainfall sensor. Rainfall sensor is to detect the rate of rainfall and intensity. The ultrasonic sensor is used to detect the water level. The 4 rate sensor is detect the water flow rate, and all the data will be proceed to the MCU ESP32 with the support of the supply, and all the data will output at the cloud data storage and computing, and will take action like speaker and alarm will provide the alerts. The flow chart of the system. For working flow of the system, it all starts by taking the reading in of the input sensor, which is the flow rate sensor, rainfall sensor, and ultrasonic sensor. All the data will be taken and stored in the cloud. After that, the main program will start to analyze the water based on three thresholds and categorize into three levels, which are low, medium, and high. If the water level detected is low, it means not flood is happening, and the system will go back to looping of the reading value. If the water level reaches medium, the system will start to calculate the water level rising rate as well as including the advanced algorithm with the rainfall intensity and flow rate. Is the rising level is the rising rate is high is fast, the system will send warning to the resident, else it will go back to the value reading loop. Lastly, if the water level is high, means flood is happening, the system will proceed to send warning like alarm and speaker to the resident and continue the state of monitoring the real-time value of the water source. The next is project layout design. Our project consists of three sensors, which are ultrasonic sensor and water flow rate sensor and rainfall sensor. The microcontroller will be placed inside the circuit box, which is visible, and ultrasonic sensor will be placed on the stand of the meter that at the lever side. The flow rate sensor will be put into pipe designed into the water source to take the reading of the flow rate of the river, and the rainfall sensor will be placed away from the water source to take the real-time data of the rainfall intensity. This is our project circuit diagram. As the not MCU ESP32 as the microcontroller, and the sensor like rainfall sensor, ultrasonic sensor, and flow rate sensor will be connected to the ESP32, and the ESP32 will communicating with the cloud platform. This is the hardware list that we will use the ESP32 ultrasonic sensor, flow rate sensor, and rainfall sensor, and solar panel, power bank as the power supply for the ESP32, speaker, alarm, and jumper wire. The next is the software list. We will use the micro software to write the report, Arduino IDE to program the system, produce draw the circuit diagram of the system, and AutoCAD to draw the 3D layout of the system. The next part is the discussion and result. Water level mapping. First, we have the water level mapping. By calibrating the ultrasonic sensor and applying the formula, the system accurately mapped the analogical reading into water level value in meter. According to the National Flood Forecasting and Warning Center from the Department of Irrigation and Drain Malaysia, the water level for Sungai Muar at Pancho is set as 0.25 meter. The water level above the 1.52 is considered as alert level. The warning level is above the 1.83, and the dangerous The dangerous line is above the 2.13. Therefore, our project is consider the water level below the 1.52 meter as low as or normal where the system will not take the action. As the medium level, the system will start to analyze the data of rainfall intensity. The next is rainfall intensity mapping. Similarly, through the calibration process, the rainfall sensor reading will be converted into millimeter per hour, per hour. The value of rainfall intensity is tabulated according to the value given by the Department of Irrigation and Drainage Malaysia. For further information, the value between from 1 to 10 millimeter per hour is categorized as light rainfall. 11 to 30 millimeter per hour is categorized as moderated rainfall. 31 to 60 millimeter per hour is categorized as heavy rainfall, and any value above the 60 millimeter per hour is very heavy rainfall. The action taken by the system based on the water level detected, we can consider as three group where is not possible or yes. If the flood condition is known, the alarm will not activated. If the flood condition is possible, the alarm will not activated. But if the flood condition is yes, the alarm will be activated to notice the surrounding resident to take the action. The discussion of the result. The mapping of ultrasonic sensor reading into the water level was successfully achieved through the calibration and conversion algorithm. This mapping function enabled the system to convert the real sensor reading into meaningful unit of measurement, such as meter and centimeter. Through the calibration and conversion of rainfall sensor reading, the system was able to quantify the intensity of rainfall in terms of millimeter per hour. The mapping of rainfall intensity value allowed the system to assess the intensity of precipitation and identify period of heavy rainfall that could potentially lead to the flash flood. The successful implementation of action mechanism by the smart flood warning system demonstrate its ability to support the decision-making process and enhance the flood preparedness by integrating the real-time data from the ultrasonic sensor and water level rising rate, fall rate, and rainfall intensity measurement. The system efficiently triggered action based on the predefined threshold. The conclusion of the result. The accurate mapping of the water level using the ultrasonic sensor contribute to the efficiency of the smart flood warning system by comparing the measured water level against the predetermined threshold. The system was able to initiate action or generate the timely alert. The accurate quantification of rainfall intensity in millimeter per hour enable the system to assess the severity of rainfall and its potential impact on flooding. The successful mapping of rainfall intensity value combined with the system ability to trigger the response action demonstrate the effectiveness of the system in providing timely flood warning and supporting flood management efforts. The successful implementation of the action mechanism demonstrate the system effectiveness in enhancing flood resilience and reducing the impact of flood events. Timely activation of the warning mechanism combined with the accurate data and reliable data facilitated proactive decision making and enable individual, community, and authorities to take the necessary action to safeguard life and properties. That's all from me. Thank you.